In this video, we are going to go over how to create a MONSUMT entry for MSC Natsran. So in this event, say you have multiple monitor points, you can use this entry to sum up your monitor points. So let's go ahead and get started. Okay, so here is the model we're working with. I think some of you may recognize this model. It's the model I've been using in various other tutorials regarding monitor points. So since we've used this example multiple times, I believe all of us are familiar with the beam configuration. It supports the loads, the expected deflections, the internal loads, and all of this is familiar to us. So that's why we're going to continue using this example. Now, this is what we want. We want to sum up this monitor point multiple times, and we'll do it at the root. So quick recap, this monitor point, it's monitoring the applied load at the free end of this beam. The total load, if you will, the total load that's being monitored is negative 10,000 newtons. So now we're going to create a one monitor point at the root, and we're going to feed it the values from this monitor point. We're going to sum up the values from this monitor point at this location. So let's go ahead and start off with here in this other window is a quick agenda. It's going to be almost the same agenda as before. I'm going to show you how to create this entry. So I'm going to show you how to create this entry. Right, okay. And then we're going to interpret the results. We're going to export the results to CSV file. I'm going to change the orientation, and we'll see what the effect is after we change the orientation. We're going to see what that changes in the summation. And then I'm going to show you a quicker way to define this entry, the MONSUMT entry. Okay, so we'll navigate to the MONSUMT entry. Let's go ahead and give this a name. We'll call this P401 summation at the root. Here, axis 1, we'll say that the final, here, I believe I actually have values. Okay. So this is what's reported. So this column, axes, oh no, this is something different, right? So this is going to consider, say we have this monitor point. Say in the summation we only wanted to consider this CY value. So all the other values are absent. How do we do that? We select only the second component here. Suppose we only wanted to consider, I don't know, maybe the rotation, the moment was 5 as an example. Suppose you only wanted to consider that component in the summation. You would consider only the 6th component. But here, what we're going to do, we're going to consider all 6 components from the monitor point. We're going to consider all the 6 components of this monitor point. So what we do here, we say consider all 6 components. And here I confused myself for a quick moment. This needs to be carried over to this other line. And then for CP, we'll ignore that. Where's the root? The root is at 0, 0, -2, so X, Y, and Z. And then I believe in the model display panel, we now get a option. We get a row for that monitor point. So let's look at this. So here is the coordinate system for this monitor point. The yellow square rather is the location of the monitor point, and then we got a label here. Okay, we're not done yet. We need to tell Natsran which monitor points are part of this summation. So if we look at this monitor point, this label for this monitor point is P1. So now let's go ahead and add a row here. Here we're going to say consider monitor point P1. And then the type is going to be a structural monitor point. This monitor point is not related to aerodynamic grid points. It's related to just regular grid entries. So here, these are structural monitor points, if you will. And we're only going to sum it up once. And then if we exit here, we'll see an additional piece of information here. It's yellow. Let's recolor this. We'll click on the recolor tab. Okay, so you notice there's one thing here that's worth mentioning. So this is the monitor point for the summation. We get a dashed line telling us which monitor points are going to contribute to the summation. If I wanted to, let's go ahead and add this monitor point maybe. So we have another monitor point 3. How would we include that in the summation? Here we would add another row. I haven't tried this, but it may or may not work. I suspect it won't work, but this is what the, if it did work, this is what the configuration will look like. And notice one thing here. I don't know if this will actually work. Let's see if monitor point. Oh, okay. I was selecting the wrong monitor point. So here we have monitor point 3 set for the type, and then the name of the monitor point is this one. So now I have another dashed line. This is saying that this summation is going to consider this monitor point and this monitor point, PB1. So if we look back here, PB1 has been selected. I don't know if this works. I'll leave it up to you to experiment on your own and see what works exactly. Here, let me delete that. And when we delete that, you notice the dashed line disappears. Let's run this. Let me see if I have P1 here. Okay, so this is P1. This is the monitor point at the end of this beam. So let's go ahead and display the label real quick. So this is P1. Let's look at what the values are after we do the summation for this point. So we'll look in the F06 file for P401, I believe. Okay, so let's copy this. And let's see what we have here. Okay, so let's do a quick equilibrium check here. Or let's find the equivalent load at the root. So we know that this freon has an equivalent load of negative 10,000 newtons. This is going to cause a moment of about negative 50,000 newton meters here. So that's what we see in the new summation. We see negative 50,000 here. And then for the shear force, we see negative 10,000. Now, let me move this monitor point. Let's see if this will work. Now, let me say one comment about this. When in the previous video, we used MONSUMT. In that video, we saw this value was actually 0. So one comment I made in the previous video was that MONSUMT does not carry over the moment, whereas MONSUMT does carry over the moment. Okay, let me see where we're at with the agenda. Right. So we created the monitor point. We interpreted the results. Let me show you a few other ways to interpret the results. So let me hide the labels actually. Let's look at the post web app. Let's look at MonPNT1. And let me hide the MonPNT1 from before. So you notice a moment ago it was visible, but I do not want it visible. I only want this summation monitor point visible. And now let's go ahead and select the MonPT1 dataset, select subcase 1, we'll select this component. And if we zoom in, make sure you have arrow plot and marker plot on. Look what I get. I get the direction and the value of this shear force. And then what about the moment? I select the component CMZ here. And then here I get the direction, if you will, of the moment and the value of that moment. And then let me list both of those values here. And then for the other value, let me display all 6 values, 6 components of the monitor point. Oh, they're all 0. Okay, now let's do another few things here. Let's experiment with this a little bit more. We'll do this. Let me see. Right. So here's one tedious thing about this. If you want to include additional monitor points in the summation, you have to manually pick each monitor point one by one. I'll show you a much faster method. Here on the top right hand corner, click on this button and you download a CSV file. Now I can use Excel to do the summation. Now there are a few ways you can do this. You can either populate each row or each column. So here I'm populating each column. If you have different names for the monitor points, it'd be P something, P2, P3, special name 1, special name 2, and so on and so on. Here I'm just taking that one monitor point. I'm just summing that monitor point again and again. So you could do this. I'm not a big fan of this approach because it makes it very difficult to, or I'll actually show you here. How many do we have here? 5, 1, 2, 3, 4, 4, 1, 2, 3, 4, 5, 6. So we have 30 monitor points here. So you could format it in this way. Let's go ahead and upload this. So here's all the values that were imported. Let me repeat this actually. Let me create a new MONSUMT entry, and then we'll call this a P405. We'll call it a duplicate with different format, if you will. Let's go ahead and consider all 6 components of the monitor points. Let's position this monitor point so we get the same values. And then here, what I'm going to do is this. Let's go ahead and renumber this. So 33. So let's make sure we have this listed 30 times. Okay, there we go. So this is another format. I prefer this format. We'll see if it works here. Sometimes it works, sometimes it doesn't work. So here, both of these are the same, mean the same thing. Take these monitor points, these 30 monitor points, and add them together. So you can see the different formats. Let's run this real quick. Let's look at these entries. Just bear with me while Natsran is running in the background. Let me copy this actually to text editor. So I'm a big fan of this other format, because then if I want to make another modification, say I want to switch it up to a different monitor point, it's easy. I just modify the line and I don't have to worry about accidentally messing something up. Here, if I wanted to make this change, okay, monitor point 5, okay, that worked, but then here, 101. You notice these have shifted over. Now I have to worry about formatting, making sure the formatting is still preserved, and so on and so on. So that's why I like this format more. Okay, let's do a confirmation real quick. Let's look at the F06 file. Let's make sure that the values are the same. So I think, what were the names again? P401, P405. So if you look here, you could do something here. You could toggle the size of the font. Alternatively, you can hold the control key and scroll. And then I'll mention this. I don't know if this is available, but on Google Chrome, you have the option of translating the text. So if you spoke another language, you can actually translate this text to your own preferred language. Here, I've copied the data over to the text editor. Even though I use different formats, so here I'm vertically stacking the monitor points. Here I'm horizontally stacking the monitor points. Even though I stack them differently, the same monitor point is repeated 30 times. So here we see that negative 10,000 times 30, that gives us negative 300,000 here and here for the second MONSUMT entry. So both of these formats yield the same values. Okay, let me see. So so let's output this result to the CSV file. Okay, so now how do we export this data from this F06 file to the H5 file? Let me download that F06 file. So I've said this possibly a million times already today, but I really want to emphasize the point that it's really difficult to read the F06 file. That's because, or at least in my opinion, the F06 file was never designed to be read by a script, at least easily. The best approach is to use the H5 file. So here, let's open the HDF5 Explorer. So these same values are in the H5 file. We're going to use the HDF5 Explorer to read the same values. So we'll go to acquire dataset. We'll go to MonPNT1, I believe. Here we have those two summation. We have the two monitor points for MONSUMT. And then if we look at the Y component, we get negative 300,000. So I can do a few things. I can create a plot. Let's go ahead and look at this. Let's look at the vertical component. Let's change this to a bar chart. Let's ignore the first monitor point. So this is the first monitor point, P401, and the second monitor point, P405. So that was these two entries here. So these are the values we're looking at right now for component 1. And here we'll look at the moment. So moment, well, they're the same essentially. You could create your plots, or you can download a CSV file. So the same table of values, that's available here too. So if we look at these two values, it's a negative 300,000 newtons. So then here we see what the moments are in this other column. Okay, so we can download a CSV file. I think you saw how I used Excel to modify these entries. Okay, manually change. Oh, right, the orientation. So let's talk about that real quick. So let me display. I don't know if I mentioned that. Right. Okay, so let's move this monitor point. Let's move it here maybe. So we'll go to this monitor point, P401, which is this top row. And now let me do this. Let me move this to the side. Let me move this to the right a little. Let me shift it over 1 meter. So we'll use -3 for the Z component. So it's been shifted, and now let's rerun this. So in this other window, let's see if I have this right. So here was the previous value. So this was the monitor point at the root. Monitor point at the root. So the position was 0, 0, -2, I believe. New position as 0, 0, -3. And let's go and look at what the values are in the F06 file. So F06, P401. So that'll be this value here. Right. Let's see if anything changes here. Okay, yeah, something does change. So the moment about the x-axis in the monitor point was previously 0. So before it was 0. But look what happens now when we shift it over the monitor point. It's not 0, as you see here. And so if we wanted to, we could actually look at the values for this monitor point, MONSUMT. Let's go and extract the MonPT1 data set. Let's go and look at shear force and then the moments about the x and y axes. Or actually, yeah, let's look at that. So before, this value was 0, but since we offset the monitor point away from the beam, the moment about the x-axis is now non-zero. So this is what the components look like. Okay, like before, you could go ahead and output this data to the HDF5 Explorer. Here, we'll do that right now. You'll notice that we're not having to deal with all the weird formatting in the F06 file. We're not having to struggle trying to read this one file. Here, we'll download this data set and we'll download the CSV file. And we'll look at this now. Do you want to reopen? Yes, okay. So these were the previous values and these are the new values. So let's go ahead and highlight these. So very similar values like before, except the second component. Before it was just 0. Right, so before it was 0. So before it was 0, when the monitor point was at the root, but then when it's offset from the root, this value is no longer 0. It's some other positive value. Okay, let me look here. One other thing about the position. Let's reorient this monitor point. So right now, the loads, if you will, are being observed by this coordinate system, by this stick figure, if you will. I have this other coordinate system. I'm going to make this monitor point, I'm going to make this coordinate system parallel to this other coordinate system. So let's go ahead and do that real quick. So if we look here at the label, this is a core 2R entry with ID 1. So what I'm going to do here is for that MONSUMT entry, I'm going to select this coordinate system here, and then this, let me make a note for myself here. Okay, so let's go and look here. Okay, so once we do that, let's go and see if we change this. Oh, right, I don't think... Right, we might have... Okay, yeah, so there is a bug here. Apologies for that. So what should have happened, and it's happened in the previous videos, this coordinate system, when you change the CD field, this coordinate system then becomes parallel to that selected coordinate system. But here in this case, it didn't work. There's a bug in the web app. We'll go ahead and fix that, and we'll have the fix implemented in probably 1 hour. It's a really simple fix. So here, this CD field, when we change that, should have changed this orientation. But here, it didn't work. That's okay. We'll continue on. Like I said, in a previous video, it did work. So if you want to explore and see how that worked, you can refer to the other video. Okay, you'll notice that I did a quick pause there. Now, the reason I did a quick pause was because I implemented a fix. Now, let's go ahead and do this. I downloaded this bulk data file. So let's see where we're at. I think the fix only took me 1 minute. Okay, so here's this bulk data file. We're going to open another web app window with the fix. So again, there was a brief pause in the video, and that's because I was fixing the issue. We'll see if this works. We'll go to the pre-web app, we'll look for that MONSUMT, and then let's go ahead and display MONSUMT 401. So again, the goal is to reorient this monitor point so the coordinate system is parallel to this other coordinate system. So to do that, you modify the CD field, which would be this field. Let's go ahead and select this coordinate system here. It turns blue. Close the picking tool. There we go. So now it's been updated. And now let's rerun this real quick. So here in this other window, let's go ahead and see. Okay, so we're going to have another table here for monitor point P401, but oriented differently. So now let's go ahead and look. Let's go ahead and run this. After this run, we'll go ahead and look at the new values for the summation monitor point. So let's go ahead and look at the F06 file. Let's look for P401. Let's copy this. Let's copy it here. And then you'll notice a few things that are different. These first two versions of the monitor point, they were all using the basic coordinate system to orient the monitor point. But here, we purposely chose the different coordinate system so we can orient this monitor point differently. This is indicated by the CD field. So here on the right side, you see CD equals 1, whereas before in the other examples, it was CD was equal to 0. Now, here we see CX, CZ, the moments were 0. But look what's happened now. Because the coordinate system is different, that summation is being viewed in a different orientation. So you could think that this stick figure, it's viewing that summation in a different orientation. That's why these values are different. Now what we can do, we can open the Post web app. We can download the MONPNT1 data set. And let's go ahead and look at the CY value. Let's turn on the arrows. So CY is negative 1.59 times 10 to the 5th. So that's exactly what we get. Okay, let's look at the moment. So the moment is 3.93 times 10 to the 4. Let's look at the moment. 3.93 times 10 to the 4. So this is also okay. Great. So thankfully, even though there was previously a bug, I found a way to quickly fix it. We were able to continue this tutorial. Okay, now like before, you need this data out to a CSV file. The goal, and I encourage anyone who is scripting, who's learning how to use Python, any developer, try and avoid reading the F06 file as much as possible. If you do rely on the F06 file, in 1 or 2 years, you'll find out that the script breaks again and you have to rewrite it. Here, that's okay. We use the H5 program or the H5 file to get that data. Let me download the CSV file. So here, I've just downloaded the same data that we were looking at. So all this data is now in the CSV file that I downloaded. And you look and see that these values are all different. So these were the values before, and then second before, and then now this is the current state of those values for the monitor point. Okay, so we covered a lot. We went over how to change the right. Okay, so I think I went over all of this. Okay, so I know this was a lot. The MONSUMT entry is going to be one of the entries you use more often than the other ones, possibly. And here, the goal in this video was just to give you an idea of what the process is like to work with this entry. I know I didn't cover this entry in great detail. If you look at this at the remarks, there's more details. If you look at the linear static analysis user's guide, let's go ahead and open that guide right now. You'll see there's even more information about monitor points. The goal in this video was not to go into great detail regarding each monitor point. The goal was to show you, okay, what's the process to create them? What's the process to display them, inspect them? What's the process to interpret the values in the F06 file? How do you look at the same values in the post processor here? How do you quickly extract these values from the F06 file to a CSV file? That was the goal. What's the procedure like? The documentation is very well written. If you have more questions, if you really want to be a professional expert user when it comes to monitor points, the documentation does a way better job than I do of explaining all the fine details in the monitor points. So I recommend referring to the documentation. Okay, and then lastly, just in case you do have a question or comment, you can reach out to me at this email address and I'll get back to you as soon as possible. And remember, everything you saw today was done in a web application. We ran Natsran in the web browser, even the F06 file. Let me confirm to you what's going on here with the F06 file. Here you can see it says MSC Natsran version, so on and so on. So this is genuine Natsran. What's actually going on here, the bulk data file is sent to the server. The server runs Natsran, and then it sends back the results. One common question I get is, hey, how do I get access to this web app? You can visit theengineeringlab.com. Here at the top right hand corner, click on the blue button, fill out the form, and we'll go ahead and give you access to the web app. Now, you have two options. You can use the web app at this website, or we give you an installer. So you can install the web app in your own company, school, or other organization, and you can use the web app all on your own in your own network. You don't necessarily have to use a special website like theengineeringlab.com. No, you get an installer, and then you can use the web app on your laptop, on your desktop. In some cases, you could possibly even use your own phone, a smartphone, to use the web app. So there you have it. That was the MONSUMT entry for MSC Natsran. Thank you for watching.